All right, we left off Wednesday of last week, right? Wednesday. As a side note, you've never seen happier kids than like the 90 kindergartners that went to the zoo with us we went to the zoo with on Friday, like running around watching crazy people. It was wild. We left off on Wednesday talking about how we measure core body temperature, how we measure skin temperature. Okay, we need to measure temperature accurately because we need to understand what is happening with core temp to understand when the hypothalamus is going to try to begin sweating, how we're going to try to dissipate heat, and when we're going to be in a situation of heat stress. Okay, so if we measure things right at reps, like you guys right now, your core temp is about 37 degrees centigrade. Okay, that's about 98.6. Your skin temp, like on your arm, is about 2 degrees lower. There's about a 2-degree difference between core temp and skin temp most of the time, because when it gets to the skin, there's convection, there's radiation, there's evaporation. So we're losing some heat on the skin. So keep those two things in mind. All right. During exercise, core temp may exceed 40 degrees Celsius, which is about 104. It may be up to 42 or 43 degrees in the working muscle. Okay, it's really warm in the working muscle. That's, almost 108 degrees Fahrenheit in a muscle. Anything when core temp gets above 40, it can begin to affect the hypothalamus and the central nervous system, and there can be negative consequences. Okay. Part of the first sort of negative consequence is you perceive it as heat stress and you feel worse. It induces central fatigue, and the hypothalamus tells the motor cortex, knock this off, right? We're too warm. We need to stop exercising so we can lower core temp. Because if it stays up for too long, there can be actual sort of real damage in the nervous system. Okay, and a weird thing happens, as you guys will see, when you get too hot, the system gets confused and it stops sweating. Okay, it stops doing the things that dissipate heat. So then you can imagine you're already too warm, and when sweating stops, then you immediately spike, getting warmer and warmer really fast, and that's what we would call sort of a heat stroke. And it can be exceedingly dangerous to have things like that happen. Okay. All right. So we've talked about core temp. Let's talk about how the body actually adjusts and regulates. Go forward. Temperature. Okay. Everything is run out of the brain in the hypothalamus. Okay. The hypothalamus is the body's thermostat. You have central in the hypothalamus and peripheral, sort of around your body and your skin and your muscles, what we call thermoreceptors. They sense a change in temperature in that area. Okay? The ones in the hypothalamus are sensing changes in blood, the temperature of the blood circulating through the brain. Okay? All of them, the central ones and the peripheral ones, signal to the hypothalamus. Okay? The peripheral ones are especially in the skin, monitor ambient temperature, okay? And all of that information is going to get sort of integrated in the hypothalamus, and then the hypothalamus will signal out to our effector organs to increase sweating, to potentially start shutting down muscle contractions, et cetera, in an effort to, we're getting too warm, let's stop all of this, okay? So the hypothalamus will signal to 4 primary places we call effector organs in an effort to attempt to maybe not cool you off, but to prevent or slow down the rise in core body temperature. The primary effector organ is going to be sweat glands. Okay. At a certain core temp, the hypothalamus tells the sweat glands start making sweat. This leads to an increase in evaporative cooling and is our primary during exercise, our primary way of losing body heat. Okay? It also signals to smooth muscles and arterioles. And what it tells that smooth muscle to do is to relax. It tells those arterioles to vasodilate, and it sends more blood to your skin. Okay? As the blood gets near the skin, it flows sort of into the skin. It's closer to the surface, so we can lose more heat via radiation and convection. Okay? That is going to be a big important thing. Problem during exercise, though, is if the blood goes to the skin, it's not going to skeletal muscle. So that can impair performance. And then at some points, and those of you that are very, very highly motivated, if you keep exercising when it's really hot, you can reverse this. And you can start sending blood back away from the skin, back to your muscles. And then you lose one of your ways to get rid of heat, and that can cause even more heat stress. Okay? We can, when we're cold, at least, signal to skeletal muscle to cause you to shiver. You will involuntarily evoke a muscle contraction to produce more heat in an effort to warm you up. Okay? So that can be an effective organ. And then we're going to have some endocrine gland as an effector organ. We'll release some hormones. They're going to increase metabolic rate, like thyroid hormone or epinephrine or norepinephrine if you're cold, and that can help us make more. Okay. Now, the big ones for us during exercise when we're worried about being too hot is going to be sweat glands and the arterioles that we can send more blood out to the skin. Okay. So this process works like this. Okay. On the top, we're exercising, or you're sitting in a sauna, whatever it is, you increase blood and internal body temperature, or you increase internal body temperature, therefore the blood temperature goes up. That is sensed by the hypothalamus, okay, which then tells sweat glands to become more active, and it tells blood to go to the skin. The combined effects of those two things are to hold core temp where it is, probably not to cool us off, right? It's just going to slow that rise if we're going to get it. If you were to step out and stop doing things, then maybe we could get a little bit of a dip in core temp, okay? But even though this says body temperature decreases, a lot of what happens during exercise is we're just blunting that rise, okay? It's just going to keep it from going up too much more, try to hold it constant and keep us safe, okay? So because blood goes to the skin, that's going to alter how the cardiovascular system regulates things during exercise. It's going to alter that normal cardiovascular response. What it really does is it exacerbates the normal cardiovascular response. And I'll show you how and why this is going to happen. Okay? As we send blood to the skin, we lose venous return. If we lose venous return, what is going to go down? Yes. Why will stroke volume go down? That's right. What do we call that? What happens? Venous return affects which parameter that drives stroke volume? Preload. Very good. Okay. Preload. Blood to the skin, less venous return, less preload, stroke volume falls. Okay. If stroke volume falls, and you need to maintain the same cardiac output to allow you to exercise, out of necessity, what has to happen to heart rate? Heart rate has to increase. Very good. Okay. Heart rate has to increase. As we lose water via sweating, plasma volume will also fall. So blood volume falls, which also further decreases Venus return and further impacts or decreases preload. So stroke volume goes down. Okay. The big thing that happens in exercise in the heat is that stroke volume is lower basically at all times. Okay. Or after about 10 minutes of exercise, this stroke volume is lower. So to maintain exercise, heart rate must increase. So what you observe when you go to exercise and it's hot is your heart rate is higher at every exercise intensity, at every pace, whatever you're doing, your heart rate is elevated compared to if you were in a thermoneutral or a cool environment. Okay. Heart rate is going to be elevated. Now, that's not a huge consequence during moderate intensity exercise. Okay. You will feel worse. You will perceive your heart rate is elevated. Exercise will feel more effortful. Okay. But physiologically, as long as you're motivated, if we're at 60, 70% of VO2 max, you're going to be okay. You're going to be okay. All right. What we call this, that progressive decline in stroke volume must be offset by an increase in heart rate. And I'm not sure if I have this on a slide or not. And I'll write it down if I have a, nope, I don't have a thing. Write this down. This here is a phenomenon that's called cardiovascular drift. Okay, drift. The progressive decline in stroke volume that leads to an increase in heart rate. Okay. As long as you're not in like super duper hot environments, you'll see this within 10 to 15 minutes of exercise. Start. Okay. It's called cardiovascular drift. And you're going to be fine for a while. But the other consequence is as heart rate drifts up, as stroke volume drifts down, right? Remember, the max stroke volume in all of you guys in the room is the primary determinant of your VO2 max, along with mitochondria and capillaries. So if because of decreases in preload, I make your max stroke volume go down, guess what happens to your VO2 max that's high? Falls. Okay. Exercising in the heat, every one of us immediately becomes less fit. Okay. That's why it feels worse when you exercise and it's hot compared to when you exercise and it's cool. It's a real physiological phenomenon that the increased temperature tends to decrease increase preload, which it decreases preload, it decreases stroke volume, which decreases VO2 max. So functionally, everybody is less fit when it's hot. Okay. That's a problem. Okay. So when ambient temperature exceeds skin temperature, evaporation becomes the most important form, right, of heat loss during exercise. That's not to say that all of you aren't losing heat via evaporation all the time. You absolutely are. But when ambient temp is over core temp, so when ambient temp is over, right, basically like 98, 99, 100 degrees, you can't really radiate or convect much heat away. There's no gradient. Okay. You're going to gain heat through the skin rather than lose it. So then evaporation becomes the big key thing. Okay. What we know, as you begin to sweat, okay, the hypothalamus makes you sweat. You will sweat about a liter per, okay, square meter of body surface per hour. Okay. A liter per square meter, okay, of body surface per hour. Now, you guys may ask me, like, how do I know what my square meter, how many square meters of body surface do I have? I don't know. Okay, Ty, Google that for us real fast. Let's see what Copilot says. How do we calculate this? My guess is most of you have a couple of liters of, a couple of meters of body surface area.
How to calculate body surface area?
Yep. It's probably height and weight and something.
Just says usually calculated using mathematical formulas based on height and weight.
Great.
The Dubois formula, whatever
Dubois.
that is, the Mosteller formula.
Okay.
Never heard
Perfect.
of these things. I don't.
Okay.
It's not even telling me what's in them. It's just
So if
saying.
you see something, fire your height and weight in there and then tell us how many square meters, okay?
Yeah.
What for a lot of you this equates to is in an hour, you can lose 2 to 3% of your body weight in an hour, just gone, okay? So if you're outside exercising in the heat for a couple of hours or doing yard work or whatever it is, it's really, really easy to lose 3, 4, 5, 6% of your body weight. Okay? So if you're a 100-pound person, you're losing 5 or 6 pounds. Right? If you're a 150-pound person, we're now approaching 8 or 10 pounds. Okay? And so you can lose a lot of weight really fast just by sweat loss. Okay? Sweat loss exacerbates our blood volume decrease, which further limits venous return and further limits stroke volume. Okay? Again, making us less and less fit. You also lose minerals and electrolytes. Okay? Hence why we have Gatorade and Powerade and Pedialyte and all of those things. But it also leads to the release of aldosterone and antidiuretic hormones, which are going to lead to greater water absorption and greater sodium absorption at the kidneys, all of which are going to function to help you hang on to water and sodium and not make urine. Okay? As you become more and more dehydrated, your urine becomes more and more concentrated when you make it. Okay? And you make less and less. What do you got, Tom?
So, body surface area can be calculated 1/6 times the product of your height and weight times 0.05. So anyway, when I fired my information in there, 95.08 is my body surface area.
What are the units on that?
Meters squared.
No, you don't have 95 meters squared. There's
Just
no
what-
way.
It's just what they're saying.
Okay,
Yeah.
that equation, we did not do something right.
That's just what PubMed said.
Okay. I believe you. I'm just saying, that doesn't seem right? That's one of those things in science, you're like, no, that ain't doesn't.
I mean, I'm guessing I usually know my values, but
It's
I'm drawing a
probably
blank.
like you need to convert it something to like height in centimeters rather than in meter. I don't know, there's probably a decimal that's wrong somewhere.
I bet you're right. Yeah.
So, anyway, okay,
Oh, it is height in meters. Okay, yeah, I messed up.
so maybe you're like 0.95. If we just move the decimal 2 places. Which would put our centimeters into meters. Excessive heat gain is a threat to your health, okay? So you've got to consider when you're gonna exercise, what's the air temp? What's the relative humidity? Is there wind? I mean, we live in Oklahoma, when there's not wind, that's the red letter day, okay? And then thermal radiation, like what's the cloud cover? What's the surface you're gonna be exercising on? You guys have been in a parking lot, like on a blacktop or whatever, and you can feel it much hotter, it radiates off, right? Those kinds of things. Or you've ever been around like in the morning and the grass has dew on it or something, and it's really hot, so the dew is actually evaporating. And as you get by the grass, it feels even more humid because there's all that extra water vapor getting into the air right around the grass and stuff. I've been traumatized by football practice, and 2-a-days from earlier in my life. That's what I have nightmares about, sort of the stickiness of the grass in those ways. We're gonna talk about that in therapy this week. And all of those things. So you got to consider this. So For any of you guys that do outside sports or are interested in being an athletic trainer, what's supposed to happen, I don't know what the laws are in Oklahoma, but in Arkansas, all high schools and junior highs have to have one of these. I know that we use them here. I know you, but this contraption that you see is called a wet bulb globe thermometer. And rather than simply measuring ambient air temperature, this device allows us to get an estimate of sort of the heat stress temperature. And what it does is it gets air temp from a regular thermometer. It has this sort of globe thermometer at the top. It's encased in like a black globe that measures sort of radiant heat and those things. And then it has a thermometer that sits right above, okay, a little thing that has water in it, and it's measuring the capacity for us to have evaporative cooling, okay? And so what this considers, right, is that gradient between relative humidity and things. This is going to get us air temp. That's going to get us that kind of radiation ability to lose things. It doesn't really count wind temperature in there, but you get a number out of all of this, and it's a much, much more accurate estimate of the thermal stress on a particular day. Okay, and if you will just look at the big thing that it does, here's the wet bulb globe thermometer down here. Okay, the biggest thing that it adds together is 70% of that value comes from the evaporative cooling capacity. Okay. From the evaporative cooling capacity. And so 20% comes from the radiation from the black globe, and only 10% comes from actual ambient air temp. And that's kind of the big deal. Now you get a temperature from all of this, and it's on the kind of normal temp scale, but you know, a lot of stress might be 88, a wet bulb temperature of 88 or something might be very high stress, whereas a 70 might be much lower stress. It's gonna not look like what you're thinking of as just kind of pure air temp. Okay. So we know the temperature rises during exercise. We know that our capacity for evaporative cooling should go up early on, but then it may become a little bit compromised as we begin to lose some sweat. So let's talk a little bit about how the intensity of exercise can affect this and how that may translate into your ability to exercise on a particular day. Okay, if you expended 10 kcals per minute, okay, from an exercise standpoint, whatever that's going to vary based upon your body size and those things, but that's not that unreasonable. Okay, 10 kcals a minute, right? Works out to basically, that's like a 10-minute mile jogging pace. Okay, 10-minute mile jogging pace. Then in 1 hour, if you did not lose any heat, you would raise your core body temperature by almost 8 degrees Celsius. Okay, 8 degrees Celsius. Remember, anything over about 104 gets to be a little bit dangerous. So you're going to go from 98.6 or some kind of normal temp all the way up, okay? All the way up to nearly 106 or 106 and a half or something in an hour. So basically you would kill yourself via overheating within an hour if you were not good at dissipating, okay? So one of the ways that we target this is in most people in the hypothalamus. It only takes about a 0.3 degree change in core body temperature in Celsius for you to get to the place where you're going to begin to sweat. Okay. So if normal is 37 degrees, you get to 37.3, then you begin to sweat. Those of you that are acclimatized to the heat, you actually sweat at an even lower core temperature. Okay. As you become more used to doing things when it's hot out, we lower that down closer to kind of resting body temp. So you'll sweat sooner, dissipate more heat sooner, and that is going to keep us cooler for longer. Okay. We know that core temp will rise in relation to exercise intensity or in relation to VO2 max. Because as you approach max, your work rate gets higher and higher, your muscles are making more and more. Okay? This is independent of ambient temperature, of room temperature. It is mostly dependent upon more muscular work, means we're making more heat in our muscles, therefore core body temperature will increase. Okay? Here are some data. I had a class in all of this stuff when I was a graduate student, and I've totally stolen the slide from there. Okay. This is relative percentage of VO2 max here on the x-axis. And remember, I told you guys that one of the ways, probably the most accurate way that we measure core body temperature is through rectal temperature. At least it was in the 1970s. So here you have rectal temp or core body temp on the y-axis. And what I want you guys to note, right, is that as our percentage of VO2 max goes up, our core temp is also going to go up. And near max, most people are going to be around 40 to 41 degrees Celsius. So there's this, it's not exactly linear, but it's a very, very, kind of positively accelerating. Our quadratic is not particularly steep there. Almost linear increase in core temp with a percentage of VO2 max. Okay. So as muscular work goes up, as we work harder and harder, we make more heat in our muscles, and it further raises core body temp. So what you can imagine then with all of this is if we overlay ambient temperature on top of this, then the lower your work rate, the greater range you have to be able to continue to increase core body temp before we hit some critical level, right? So in that way, this sort of graph explains why it's hard to exercise at 80, 90% of your VO2 max for very long. It's hot outside. Because you're making so much heat in your muscles, you're already raising your core temp up. And if we overlay a very hot environment where you're trying to gain heat or having trouble dissipating heat because of the nature of the environment, then those two things work together to really limit exercise performance. Okay? So you can go and walk when it's really hot out, and you may feel worse than if it was cool and you were walking, but it's not that big a deal. But for those of you that are very fit and you need to work out like above lactate threshold or work out close to your max, it's going to have a very, very dramatic effect when it's really hot outside. Okay. Again, I stole this from a previous class that I was in. These are some handmade graphs, and I just don't want you guys to worry about this. The big thing that I want you to know is, right, when it's hot, heart rate is going to be higher at all sort of exercise intensities. Don't worry about lactate. Don't worry about VO2 on those two things, okay? Talked about the heart rate. I should probably just take this slide out entirely. Okay, we'll finish today with a couple of things about some heat disorders, and then we'll talk about acclimatization, start off on Wednesday, and we'll get out of here. All right? Anybody ever had like heat illness, been dehydrated, and you feel like you've had some kind of heat illness? Okay, a couple of us, okay, right? Much more common in sports like football and things like that, where you're wearing a bunch of pads and things where it's going to increase sweat rate, increase the work rate and those things. But we kind of graded out heat disorders. The most mild is something called heat cramps, okay? It's very likely due to dehydration and loss of electrolytes from excessive sweating. Or you have the excessive sweating and then you don't replace with sort of water and electrolytes correctly afterwards. On those kinds of things, generally we can treat heat cramps with fluid and saline. This is Oklahoma. I assume it was much like here, like it is in Arkansas. Anybody when it was hot outside ever had a parent or a grandparent or someone encourage you to drink pickle juice? Yes, which really turns my stomach. But what's pickle juice? It's water with salt in it. Okay, and so I mean it's sort of makeshift Gatorade in that particular way. And so that's going to be a thing that prevents all of that. The biggest way to prevent heat cramps, and for that matter, all heat illness, is to drink lots of fluids while you are exercising with hot. That can then get into your system and offset some of the fluid loss via sweating, and it can help you maintain cardiac output and those kinds of things. Okay, now, the next kind of most severe is it's not super common, but it's somewhat common, is a thing called heat exhaustion. When you have heat exhaustion, you feel fatigued, you feel exhausted, sort of anecdotally in that way, that you may be dizzy, you may vomit, you may faint. You could be cold and clammy, usually much more cold and clammy than hot and dry. You have a reduced blood pressure, so you're hypotensive, and you have a weak and rapid pulse because you're dehydrated and your stroke volume is low. Okay, heat exhaustion. Most of us have had heat illness, and probably what we have is heat exhaustion. Okay, regulatory mechanisms cannot dissipate heat fast enough because of an inadequate blood supply to the skin. As I had said, guys, what tends to happen when you get too hot is the hypothalamus gets confused and it stops sending blood to the skin, which then immediately exacerbates all of our problems. Okay. Someone that we think is having heat exhaustion, we need to get them in a cool environment. We want to elevate their feet to increase venous return. Okay. Give saline if conscious, or some kind of intravenous. Saline if they're unconscious. We want to give fluids. Right. We want to monitor core temperature, make sure those things. The big deal here is you feel like shit, but generally you're still able to sweat. Okay. That's why your skin may feel cold and clammy. You're still able to sweat. Okay. The next one, a heat stroke, is the most dangerous one because we've shifted from still being able to sweat into not being able to sweat. Okay. Internal temp, well over 40, no sweat. Okay. If it's hot out and somebody has stopped sweating on their skin, they need to go to the hospital immediately. We need to pack them with ice around them and those things. We've got to get them cooled off. Okay. Weirdly, you have a very rapid pulse and breathing. Blood pressure increases because the system is getting very, very confused. Oftentimes, this is accompanied by a loss of consciousness and severe confusion. People may not know their name, they may not know where they are or what's going on. Mentally, cognitively, they're very confused and they're having problems. This is the one where we've basically counteracted our regulatory mechanisms. We get this rapid increase in core temp on top of it already being high, and it can be extremely dangerous and leads to death. Okay. It's not always associated with a constraining condition. Tends to be weirdly common when it's warm but not super warm but very humid. Okay. All right, we'll stop here. We'll cover acclimatization on Wednesday, and we'll start with the body comp Wednesday. All right. Have a good couple of days. We'll see you there.